The Glass Z31 galaxy, which formed barely 300 million years after the Big Bang, set the record for being the oldest galaxy ever seen by scientists in one of the James Webb Space Telescope's first pictures. Since July 11, the telescope has been completely functional. It has already astounded experts by producing clear photos and exciting discoveries. Prepare to hear how the James Webb Space Telescope has already discovered an exoplanet with one of the necessary elements for life, created an image that covered a region of the sky half the size of the Moon, and revealed Jupiter's rings in a way that has never been done before. Hello everyone, welcome to our channel. Here we keep you updated on all the exciting findings and mind-blowing revelations in the field of robotics, AI, and future technologies. Therefore, think about subscribing and activating the bell notification to receive tons of fascinating robot material. Without further ado, let's get into the subject. Compared to the Hubble telescope, the James Webb Space Telescope offers several benefits. Webb is located around 1.5 million kilometers away from Earth, 4 times further than the Moon. The Hubble telescope, which is located 547 kilometers from Earth, cannot be interfered with by satellites or space stations at this distance, therefore its photos are unaffected. Additionally, the Hubble telescope primarily uses visible and ultraviolet light spectrums for observation. The NIRCam for near-infrared and the MIRI for mid-infrared spectrum are both included in the JWST. According to astronomer John C. Mather, the telescope is so powerful they could see a bumblebee flying in space at the distance between the Earth and the Moon. The telescope can view the oldest galaxies and stars at the universe's edge thanks to infrared vision. Many planets, stars, and galaxies are shrouded in a thick layer of gas and dust that the Hubble Space Telescope cannot see through. However, JWST can see through anything like an X-ray. The JWST's 6.5-meter diameter mirror is one of the biggest differences. The biggest mirror deployed into orbit can take in a lot less. Thanks to such unusual tools, it is approximately 3 times as huge as Hubble's 2.4-meter mirror. Even minutely luminescent objects were seen in the JWST's initial photographs, which were startlingly crisp. The deepest and most detailed perspective of the early cosmos is shown in this photograph. While the Hubble telescope takes many weeks to gather comparable deep-field photos, JWST was able to capture it in just one day. There are thousands of galaxies seen in the JWST's deep-field picture. A collection of galaxies that make up the SMACS 0723 galaxy cluster can be seen in the center of the image. Because of the gravitational lensing effect of that combined mass, light beams from farther away galaxies behind it seem twisted. Since many galaxies are so small and faint, no telescope has ever picked them up. Our solar system served as the JWST's launching pad. Scientists chose to take a picture of the gas giant while the telescope is still being tested. This is Jupiter as it was recorded by the telescope. The planet has participated in several picture sessions since then. Researchers used this method to evaluate the JWST's actual capabilities, and it far exceeded their predictions. Because of intricate atmospheric occurrences, the James Webb Telescope was able to detect the planet's famed stripes. It also managed to catch the Great Red Spot, an enigmatic superstorm that was 10,000 miles wide and 16,000 kilometers across. On the left, photos of the other moons, Thebe and Metis, as well as Jupiter's satellite Europa, may be seen. In addition, JWST recorded portions of the planet's rings. Rings are on Jupiter. The weak rings of the gas giants are extremely difficult to detect and photograph since they're scarcely distinct from Jupiter and other brilliant space objects. The telescope next turned its attention to the extremely far-off WASP-96b exoplanet and quickly produced breathtaking results. The planet was found by astronomers back in 2013 in the constellation Phoenix. They discovered that it's a gas giant around 1,150 light-years from Earth. Although its diameter is 1.2 times that of Jupiter, its mass is less than half that of Jupiter. The exoplanet is as fluffy as cotton candy as a result. Compared to Mercury, it spins significantly closer to its yellow dwarf. The globe becomes over 1,000 degrees hotter as a result. Clouds and haze were observed by JWST in the planet's atmosphere. Additionally, it discovered water traces that were suggested by certain gas molecules in the planet's atmosphere. The scientists were ecstatic. For the previous 20 years, Hubble had been looking for water, but it wasn't until 2013 that it finally found some indications of it. JWST almost immediately produced a significant finding. Although this is fascinating, discovering extraterrestrial life on WASP-96b would be more thrilling. But according to astronomers, the first step in this journey is the discovery of physiologically important chemicals like water, oxygen, carbon dioxide, and methane. If the telescope also discovers these materials on rocky planets, it would be obvious that we should begin searching for indications of life there. Another JWST image shows the Southern Ring Nebula, which is 2.5 thousand light-years away from Earth. It's a growing gas cloud encircling a dying star. The star seen below has been responsible for this cloud for thousands of years, not the star in the center. At least 8 layers of gas and dust have been discharged. The extremely brilliant center star combines these emissions to form intricate rings of planetary nebulae and pierces them with its light. Additionally, this is how sunlight penetrates through cloud gaps in Earth. Additionally, Hubble has already produced excellent photos of the Southern Ring and several other nebulae. It demonstrated to us that these are vibrant, tremendously complicated systems rather than merely clumps of gas. JWST, however, performed much better. The planetary nebula was visible, but it also revealed a vast region of space behind it that was dense with galaxies. One of them is that brilliant narrow sliver of light on the left. When compared to the Hubble image, you can see how detailed the JWST image is. The bright stars in the Hubble image have 4 beams, but the stars in the JWST image have 6 points of light, which is another distinction. This is because the secondary mirror for the Hubble telescope's circular lens hangs in front of it on 4 extensions. Contrarily, the JWST lens includes 18 segments of the hexagonal mirror. Now look at this magnificent picture. What is this terrifying purple tidal wave? The spiral galaxy NGC 628 or M74, around 32 million light-years from Earth in the constellation Pisces, was seen in this fashion by JWST. Why does it differ so substantially from the galaxy seen in this Hubble image? This is a result of JWST's distinct job. It had carefully examined the threads of gas and dust that obstructed most stars' light. Even so, a few stars may still be seen through the curtain. The image is made more dynamic by the presence of places where new stars are forming in the remains of supernova explosions. Let's examine another amazing picture nevertheless. This is the JWST instrument's biggest picture, which spans nearly 1/5 of the Moon's diameter. About 290 million light-years from Earth, it depicts a tight group of galaxies known as the Stephan's Quintet in the constellation Pegasus. This quintet's 4 out of 5 galaxies appear to be engaged in a gravitational dance as they approach and occasionally collide. The 5th one, located 14 million light-years beyond Earth, is silently observing this show. It's a vibrant and captivating show. We've indeed had several opportunities to enjoy it thanks to the Hubble telescope, but JWST had a fresh perspective on Stephan's Quintet. Astronomers combined almost 1,000 distinct JWST photos with a combined pixel count of more than 150 million to generate this enormous mosaic. The photograph of Stephan's Quintet reveals some previously unseen information. Numerous bright blobs, far-off background galaxies, sparkling clusters of millions of newborn stars, entire regions of star formation, long tails of gas, dust, and stars ejected from several galaxies as a result of gravitational interactions, and even enormous shockwaves as the galaxy NGC 731-8b pierces the cluster are all visible. JWST was able to pierce through the thick layer of gas and dust into the galaxy's core, which is where the active supermassive black hole in the center of the highest galaxy, NGC 7319, is located. The telescope found heated gas close to the black hole and sent a stunning amount of detail about it. The image of this amazing cosmic cliff, captured by the James Webb Space Telescope, has even more brand new information. This is the Carina Nebula's NGC 3324's outermost star-forming area. Intense ultraviolet light and stellar winds from incredibly huge hot newborn stars carve out the nebulous wall. Researchers were astounded. Again, JWST generated a far crispier image than Hubble, which is especially apparent when the images from the 2 telescopes are overlapped. Burning spots may be seen in the image from the James Webb Space Telescope. Very far away, galaxies, not stars, are what they are. The bluish haze that appears to be coming from the celestial mountains is hot, ionized gas and dust that is being continuously expelled from the nebula by newborn stars. So which one is your favorite now that you've seen these incredible pictures? Tell us in the comments box below and hit like for the video. Make sure to subscribe and ring the notification so that you don't miss anything from us. Thanks for watching.